have Eric, Peli, and Thomas.
Thank you. Hey, Peli.
Yeah, we're going to be standing around.
Hey, all.
Well, I'll start.
Okay.
My name is Peli. I started MakeCode. I'm not doing MakeCode anymore, but I'm really happy to be here and looking at this great community with Blockly. And today, Eric mostly is going to be doing our demos around the simulators in our editor, and it's a really great extension point that I think people can leverage to create these kind of immersive experience. And yeah, Eric.
Cool. All right.
And we're here to answer any questions if you have like technical question that's deeper. Yeah.
Certainly. All right. We have Tom Ball.
Yeah, I'm Tom Ball. I helped start the MakeCode team too, but I've retired from Microsoft. I am still actively working with these gentlemen.
Cool. All right. Okay, and I'm the Eric Anderson that you see there on the slide. All right, so this kind of dovetails nicely into what Richard and Joey were talking about. MakeCode has, here we go. All right, quick agenda. Probably don't need to go into what is MakeCode. I think everyone's pretty familiar at this point. If you would like to know more about MakeCode, please visit our booth in the hallway here. Even if you do know what MakeCode is, drop by, say hi. And how is it extensible? Richard and Joey talked about that a bit. I think we just saw this slide as well. But MakeCode has been extensible for a long time in the way that you can add custom functionality at the TypeScript level and then expose that as a custom block in the toolbox. It's also very easy to package up this custom functionality and share it as an extension that others can then import into their projects. Now, sometimes when you're developing new functionality like this, you might be targeting some hardware or something like a peripheral, NeoPixel or something. So in the past, we've, in kind of a custom one-off way, we've introduced custom UI to represent that peripheral. And what we wanted to do was open this up to partners and third parties that would allow them to pop in some custom UI alongside their extension when you load it. So here, this slide kind of gives away the whole story, but I will talk through it. So up here, when we talk about the simulator, what we're talking about is this virtual microbit up here. So as the user is developing their code here, they can quickly iterate and test and refine their code. They can get that feedback loop. It's very tight. But now here you can see I think I have a laser on here. Maybe. So what I've done here is I've imported this extension called Robot. Robot is a very interesting extension in itself. It's developed by Peli to solve a different problem, a different kind of a bottleneck where we have a lot of different robot chassis in the microbit ecosystem. They're all very similar in form factor, but they all have totally different blocks to drive them. This extension is interesting in that it tries to unify that. So now, as soon as you import this extension, your dev loop is suddenly no longer fluid. You cannot just quickly make a change, test your code, and refine. You have to flash a microbit, find a physical device, test it offline in the real world, and then go back and make a change. So it's very slow. Additionally, if you're in a classroom setting, you may only have a few physical devices on hand, but a whole classroom of kids. So they may have to wait in line to test their code. It becomes very inefficient, very slow. With simulator extensions, it allows your extension, in this case the robot extension, to pop in its own UI in an iframe. And you can display whatever you want there. So in this case, we've implemented a little robot simulator. It runs, I've got a little video of it, so I might just fast forward to that. So what we can see here is we've implemented a quick line follower. We're able to do this in just a few minutes just by testing in the simulator. And when you download this to the physical device, it runs pretty much the same as it did in the simulator. We've got a little 2D physics engine in there, nothing fancy. Let's see. Okay, so I guess before I go into the video of that running, we'll talk about how we enabled this for partners and while keeping our users safe. So first of all, obviously, we run it in an iframe. It's sandboxed. They do communicate over a two-way kind of a pub-sub mechanism, just window, post message. The protocol is totally up to the extension and its, the blocks extension and its simulator counterpart. So we also, we pin the simulator extension that is published with the blocks extension to a specific commit hash in GitHub. And we have a configuration file that the extension developer will just open a PR to update that commit hash whenever they need to. And that way we can really be kind of in the loop on what is it that we're surfacing in the MakeCode editor. This is just kind of a quality control process. And then also we need to approve these extensions for addition into the MakeCode editor. We want to be careful about what is surfaced there to users. Make sure it's not a bad experience, but mostly just not a malicious experience.
And just, you don't need any of that to do local development and
Right.
building a simulator.
Exactly. And we're super happy to work with anybody who wants to develop one of these. It's really a low friction process. Okay, so we're going to go back to that robot extension, and hopefully this video will play. Okay, so here it is. There's a robot extension category in the toolbox, and you can see the little, the code is running on the microbit. There's a two-way message-based communication here. Oh yeah, you can drag an obstacle over. You see here, you can see the IR sensors sensing the line. You can see the sonar range sensor represented as sort of this wave in front. And also, I think we've got a full screen. So you can pop into full screen if you just kind of want to see it larger. It's kind of fun to watch, but we'll move forward. And so that really tightens up that dev loop, right? And it lets all the students in the classroom iterate on their code without having to have a physical device. Okay, now here's another one, and this is something that, here we go. This is called Device Shield, and it's a new peripheral for the microbit. Display Shield, thank you. Adds a color display to the microbit. You could imagine in a similar way, it'd be very difficult to develop for the Display Shield if you don't have one. And so we've got another simulator extension that just pops in, a virtual Display Shield here for you. And it comes with its own blocks categories, and there's a whole protocol for drawing primitives, and I think there are more libraries coming. I feel like I'm taking up all the airtime. Peli, you got anything? Okay, all right, yeah, they pop into full screen. You can see here, there's a two-way communication. If the microbit is happy when it's on, it's sad when the display shield's off, so just kind of illustrate the two-way protocol. And let's see, yeah.
We have time for questions.
If you want to get started developing your own simulator extensions, just go to aka.ms/simx. That's also where this QR code will take you.